Hi all, our next topic is Module 5 Fourier integrals and transforms. If f of x is any periodic function, then it can be represented as a Fourier series. We already studied that in first semester. If f of x is a periodic function, then it can be represented as a Fourier series. If f of x is non-periodic, then it cannot be represented as a series but can be represented as an integral called Fourier integral. Okay, so if f of x is periodic, we can represent that as a Fourier series. If it is not periodic, it can be represented as an integral called Fourier integral. Fourier integral theorem. If f of x is piecewise continuous in every finite interval and has right hand derivative and left hand derivative, and if the integral minus infinity to infinity mod f of x dx exists, then f of x can be represented by a Fourier integral. F of x is equal to integral 0 to infinity a omega cos omega x plus b omega sin omega x d omega, where a omega is equal to 1 by pi integral minus infinity to infinity f of v cos omega v dv, and b of omega equal to 1 by pi integral minus infinity to infinity f of v sin omega v dv. So this is the Fourier integral equation. You study that. Next, at a point where f of x is discontinuous, the value of Fourier integral. If f of x is discontinuous in a point, then the value of Fourier integral is equal to average of left and right hand limit of f of x. If f of x is discontinuous in a point, then Fourier integral equal to average of 1 by 2 of the left hand limit and right hand limit. So that is equal to 1 by 2 into f of x0 minus plus f of x0 plus. Next, Fourier cosine integral. If f of x has a Fourier integral representation and f of x is even, then b of omega equal to 0. Then the Fourier cosine integral is given by f of x equal to integral 0 to infinity a of omega cos omega x d omega, where a of omega equal to 2 by pi integral 0 to infinity f of v cos omega v dv. That is similar like Fourier cosine and the sine series. Okay. Next, Fourier sine integral. If f of x has a Fourier integral representation and f of x is odd, then a of omega equal to 0, then the Fourier sine integral is given by f of x is equal to integral 0 to infinity b of omega sin omega x d omega, where b of omega equal to 2 by pi integral 0 to infinity f of v sin omega v dv. Next, consider the problem. Find the Fourier integral representation of the function f of x is equal to 1 if mod x less than 1, 0 if mod x greater than 1. And hence show that integral 0 to infinity cos omega x sin omega by omega d omega is equal to pi by 2, 0 less than or equal to x less than 1, pi by 4 when x equal to 1, 0 when x greater than 1. So here first we have to find the Fourier integral representation of the function f of x, and hence we have to show this. Okay, here given that f of x equal to 1 if mod x less than 1, so this can be written as minus 1 less than x less than 1, 0 if mod x greater than 1. Fourier integral is given by f of x is equal to integral 0 to infinity a omega cos omega x plus b omega sin omega x d omega, where a omega equal to 1 by pi integral minus infinity to infinity f of v cos omega v dv. Here the interval is minus 1 to 1. So substitute here 1 by pi into integral minus 1 to 1 f of v. In that interval f of v is 1 into cos omega v dv. That is equal to here this is of the form integral minus a to a integral minus a to a f of x dx. In that case we have to check if the function is even or odd. Here the function is cos. Cos is an even function, so this can be written as 2 into integral 0 to a f of x dx. Okay, so using that formula we can write integral minus 1 to 1 as 2 into integral 0 to 1 cos omega v dv. Integral cos omega v is sin omega v by omega. Then applying limits we get 2 by pi omega sin omega. Okay, next b of omega is equal to 1 by pi into integral minus infinity to infinity f of b sin omega v dv. Here the interval is minus 1 to 1, but sine is an odd function, so the integral value becomes 0. Substituting these two values in equation 1, we get f of x is equal to 2 by pi integral 0 to infinity sin omega cos omega x by omega d omega. Next we have to prove that integral 0 to infinity cos omega x sin omega by omega d omega is equal to this function. Okay, in the question f of x is equal to 1 if mod x less than 1, 0 if mod x greater than 1. Here x is equal to 1 is not mentioned, so x equal to 1 is a discontinuous point. So we already said that in a discontinuous point, at a discontinuous point Fourier integral is the average of left hand and right hand limit of f of x. Using that property we can find the left and right hand limit of f of x at x equal to 1. So f of x is equal to f of 1 plus f of 1 minus by 2, that is equal to f of 1 plus is the right hand limit, that is 0 when x greater than 1, that is 0, plus right hand limit left to the 1 value is 1, so 1 by 2, that is 1 by 2. So at x equal to 1 f of x is 1 by 2. Substituting all these we get f of x is equal to 1, 0 less than or equal to x less than 1, 1 by 2 x equal to 1, 0 x greater than 1, and pi by 2 multiplied into the bracket we get integral 0 to infinity cos omega x sin omega by omega d omega equal to pi by 2 if 0 less than x less than 1, pi by 4 when x equal to 1, 0 when x greater than 1. Now consider another particular case when x equal to 0. In x equal to 0, substitute x equal to 0 in this equation, we get integral 0 to infinity cos 0 sin omega by omega d omega equal to, at x equal to 0 the value is pi by 2, equal to pi by 2, and this is called a limiting case of sine integral. Okay, thank you.